Okay, so first up, we're solving this one out. When solving a problem like this, you notice that they're both in standard form. Whenever you're given two equations in linear standard form like this, the way to solve them is using elimination, which is the one where we add the two equations together. If I go ahead and add these straight down, I'm going to do 4x plus a negative 4x. What's 4x plus negative 4x? 0, yeah. And so that's just a 0 down here. And then I'm going to do 2y plus 3y. 2y plus 3y is going to give us 5y. And I don't need to write in the 0, notice, because 0 plus 5y is just 5y. And then we also do the 9 plus 16. We're adding everything through. So you end up with 5y equals 25. And notice this one works out beautifully at this point, because that is so much simpler to solve now that we've gotten it down to just 5y equals 25. And so, of course, we would divide both sides by 5, so y equals 5. Now, I'm not done, though. Once I've found y, I still need to find x. You remember what we do in order to find x?
Plug it in.
Plug it in. That's that big idea I want you to have. As soon as you find one variable, you take that variable and you plug it in. And remember, you can plug it into either equation. It doesn't matter which one you plug it into, but plug it into one of the two equations and solve that. In this case, after we subtract that 10 from both sides, we got 4x equals a negative 1. We divide both sides by 4. X equals a negative 1/4, or negative 0.25 if you prefer a decimal. Yes, this one actually gives us a non-integer answer. And that's okay in this case. Thankfully, the fraction here is the second one we found. We don't have to plug it back in, because that would be much more difficult. All right, now with this one, notice that if we just started by adding straight down, we'd end up with 4x plus 2y equals 6. This would still have both the x and the y in it. That's not a good thing. So in this case, we're not going to start by adding them together. We're going to have to do something first. And that something is multiplying one or both of the equations by something so that the x's or the y's will add to 0. Now in this particular problem, it's set up to where we're going to have to multiply the second equation by something. What can I multiply the second equation by to make something add to 0? Yeah. 2. 2 would work. Because if I multiply it by 2, this will become a 4y here. And so then those will add to 0. Now 2 is not the only option though. What else could I multiply the second one by? 3, yep. So if I multiplied it by 3, then this would become a minus 6x over here. So either way is fine. It doesn't matter which way you did it. Now the first way that was suggested was 2, so let's go ahead and do it with the 2 here. But either way, you'll end up with the same result. And so when you do that, when you do this multiplication, I want you to still write out both equations. Even though we didn't change the first one, write it out still. Because by doing that, you keep yourself from going and grabbing the wrong equation later. And then once you have it to this point, you should be able to solve it from there. All right, so when we go through and solve it out from here, when you add them, you get 2x equals 10, so we can then find that x equals 5. Then remember, plug that back in to find the y. So I plug that back into either equation. Now, it can go back into either one of the original equations. Sometimes I get the question, could I plug it into this one? Yes, technically you can, but I normally don't suggest it. Normally I suggest that you always plug it into one of the original ones. That way if there's any kind of an error that happened down here, you won't be building up on that error all over again. So I'll usually go back to one of the first ones. In this case, I plugged it into the very first equation. Then we solve it out. So we got 4y equals negative 28. So y equals negative 7. So our final answer as a point here is going to be 5, negative 7. One of the big things I want you doing is noticing when to use each method. And notice on this first system, we have the second equation solved for y equals. Since we know what y equals, I'm going to want to use that substitution method that we learned about earlier, where since I know that y equals x minus 5, I'm going to replace y in the other equation with that x minus 5. So it goes x minus 5 plus 3 equals 2 times x minus 3. So there all I've done is substitute in, plugged it in. Then we go ahead and do the math. So negative 5 plus 3 is a negative 2. Distribute in the 2 on the right side, 2x minus 6. And then we subtract x from both sides, add 6 to both sides. You got x equals 4. And then again, to find y, I plug it in. And again, we can plug it into either equation, but it doesn't really matter which one, unless one's easier. And I think the second one here is definitely easier to plug x into. Because if we do that, we end up with y equals 4 minus 5. Well, that just means y equals negative 1. That's it. We're done with that one. So we get 4, negative 1 as our answer. The second one, this is the newer stuff. This is the elimination method. And this one is the toughest one we've done so far, because on this particular problem, there's nothing that you can multiply just one of the equations by in order to make the x's or the y's cancel out. At least no whole numbers. Don't bother going into decimals or fractions. That just is a headache. Instead, we can multiply both of those equations by different numbers. So I'm going to multiply both of them by different numbers here. And as I look at them, I have to first decide, do I want the x's to cancel out or do I want the y's to cancel out? And you can do either. But in this particular case, the thing that jumps out to me is that I have the plus and the minus already set up for y. If two numbers are going to add to 0, one has to be positive, one has to be negative. So because of that, I'm going to make the y's cancel out. So that's going to be my focus. So if I'm going to try to make the y's cancel out, I say, okay, I got a 3 and a 5. And I say, okay, what do both of those go into? Well, I can make both of them into 15. So that means I'm going to multiply the top equation by 5 and the bottom equation by 3. And so that's kind of how we go about thinking about it, is it's looking at it and saying, what can I turn them both into? All right, so we multiply through. And then, having done that, we can go ahead and add them straight down. So we do the 15x plus the 6x, that's going to give us 21x. And again, 15y plus a negative 15y. We tend to assume that it's going to add to 0, but always actually take that moment to check and make sure that, yes, in fact, that will add to 0. It will help prevent a lot of possible errors in the future. And yes, it does add to 0. And then 15 and 27, that's going to be 42. Divide both sides by 21. X equals 2 here. And of course, once I know what x is, plug it in to find the y. Plug it into either equation. I'm going to go ahead and plug it into the first one here. So we got 3 times 2 plus 3y equals 3. So 6 plus 3y equals 3. Subtract 6 on both sides. And then divide both sides by 3. And you get y equals negative 1. So our final answer for the second one should be 2, negative 1.